Example number 1 is a simple circuit with one independent voltage source and a single 1K resistor. The simulation shows that 5 milliamps of current are flowing in the counterclockwise direction. Let's analyze the circuit to see if we get the exact same value as such. All right. The first step in nodal analysis is to identify the nodes. All right. As part of that, we're going to assign a reference node. Because we're dealing with voltage and it is a potential, it has to be made with reference to some point. So let's take this node right here and call that the reference. Okay. Essentially what you're going to do is assign the voltage at that reference is equal to 0 because you're measuring all voltages with respect to that. And then we have another node here. I'll just put it right there and call that node 1. Okay. All right. After you've done that, for each node, okay, perform KCL. Right. Right. So for node 1, we have, well, in order to do KCL, we need to go ahead and assign the currents that are coming in and assign the currents that are going out. So let's go ahead and choose for this direction going in I1 and this direction going out of that node I2. Okay. Kirchhoff's current law says that for every node, the current that's going in is equal to the current that's coming out. Right? Another way to say it is if we assign the signs where negative is the current that's going in and positive is the current that's going out. So for node 1, the negative I1 plus I2 should be equal to 0. There are no other branches. Okay, and that seems obvious, right? Which essentially states that I1 is equal to I2. There's only one branch in and one branch out, so the current coming in must equal the current coming out. Okay. All right. So for each node, we go ahead and do the KCL. And then after that, for each branch, use Ohm's law to describe the current through that branch. In this case, we essentially have one branch we're looking at, that is for I2. Okay. Well, Ohm's law says the following, that the current, the voltage across that resistor, which is actually V1 with measured to reference, okay, so it's essentially V1 minus Vref, is equal to I2, which is a current through that resistor times the resistance R1. Well, V1, if you take a look, is actually equal to 5 volts. And Vref, well, it's 0. Is equal to I2 times what is R1? R1 is 1 kilo ohm. Therefore, I2 is equal to phi divided by 1,000, which is equal to 5 milliamps, which is what our simulation showed here. Okay. This is our first example. The second example will extend upon the first example.